Hi everyone, Pete here in my teleworking mecca. In this video I will give you a short demo of a new forecast tool called the Whole Story Uncertainty and Probabilities Viewer. Now the acronym for that is WSUP, which I believe is pronounced "What's up?" At least that's what the younger generation goes with, so I'll go with that as well. Anyway, What's Up is a tool designed to help you to efficiently evaluate NBM output in search of targets of opportunity, particularly with regard to impact weather. I've been waiting for this type of tool to become available, and now with NBM 4.0 it is now here. As you likely know, there just isn't enough time in operations to look at all of the different inputs into NBM and look at every grid, look at run-to-run consistency with each grid. Time just isn't there. It's much easier to just load and go. From a job satisfaction perspective, however, that's not very satisfying. It can be much more satisfying to use science to outperform model guidance and hit an event that you might otherwise miss with the load and go approach. While our NWP guidance has markedly improved over the past decade, it can miss events, particularly more extreme events, from time to time. What's Up is a tool that can help you find these events and help you evaluate the adjustments that you can make to NBM. It could also be helpful for collaboration with other offices, using science, using evidence that you find through this tool, rather than simply using gut instinct or guesswork. So I will now go through a short demo and show you how to access and interpret the data that the tool provides. I hope you'll find it beneficial enough to start trying it out on the forecast desk. So here's what the What's Up page looks like. The URL is shown at the top. When you enter that URL, you'll be asked to log in using your CAC account or your LDAP login. So I just logged in, so here is what the display looks like. So this page has a lot of information that you can display and interpret. I'll just briefly run down how it's all set up. Of course, you have the main display in the middle here. You have tools to adjust that display on the upper left side of it here, zoom and pan. Of course, you can just hold down the left button and drag the map if you wish, and use the zoom tools to just zoom on in. And I'm going to zoom way in on Florida. I don't know how clearly this is going to appear in the video, so you might actually display this site and go through the steps I'm going through as I do so you can see it more clearly. So you see a shaded image with color for the field we're looking at, along with individual forecast points selected across our area of responsibility. You can tell what field it is at the top. As you move the mouse around, you'll see the actual field you're looking at. In this case, it's max temperature. And on the upper right corner, it also shows the same field. What model run you're looking at. In this case, it's the 12Z run on Thursday. And the forecast is the 66-hour forecast, valid, I think it's going to be a Saturday, max temperature forecast. On the left side, you can change the forecast period and the model run you're looking at. So I can click on these different additional days, and as I do so, you'll see the data here change. Now I'm looking at valid for Sunday's forecast high temperature, and then I'll click again, you'll see it now it's Monday's. And as I click through it, you'll hopefully see some of the data set points change as you're looking at different days. It's a somewhat consistent forecast, but there you see some change, and change in some of the color. Now let's see, on this particular forecast, I want to see how consistent the model, as the NBM output has been over the last several runs. So that can use this column here for that. Here I'm looking at the 12Z run on Thursday, but I can click here minus 12 hours, and now I'll be looking at the 0Z run. And I can see, and then 24 hours back. So I can see run to run if there's been much change in this particular forecast field very quickly. At the top, we are focusing on the actual data you're displaying. So we have the NBM 4.0. There's another option, I think, for the GEFS, but I think we're focused here just on the NBM. We're not worried about domains because you're mainly going to look at CONUS here. Of course, you can focus on any one particular WFO if you want, or state, whatever you wish to do. We have the initial run that is currently being displayed, and the forecast hour. Now, NBM is run hourly, not 6 hourly or 12 hourly. So up here is where you might change and look at a different hour. So if I click on this menu, and see I can go back 1 or 2 or 3 hours back. So I can click 10Z. When you change something here, you'll see a submit button, so you have to click submit. And now I'm looking at the 10Z run. So when I look at this now, and look at the run-to-run consistency, I've noticed it's not going to work exactly the same. It's not going to go back 12 hours. In this case, it only goes back 1 hour, 1 hourly run. 24 hours goes back 2 more hours, so I'm not sure exactly. This might be a bug, but you can use this at least to look at some sense of run-to-run changes. I'm going to go back to 12Z here. I hit submit, and then to the right of that we have all the different grids based on the NVM. We see surface fields, max min temperature, hourly temperatures, apparent temperature, QPF, weather, and so forth. We also have humidity fields as well, including dew point temperature. Under aviation, we have those related fields: wind, low-level wind shear, ceilings and visibilities, base heights, probabilistic information on ceilings and visibilities, along with convection information, CAPE and simulated reflectivity and so forth, probabilities for thunder. To the right of that, we have winter fields, which we're not going to use very much here in Florida, but you never know. If you need it, it's right here for snow and ice, probabilistic information, and so forth. Then you have fire weather fields, humidities, Haynes index, mixing heights, winds, transport winds, and so forth. And then finally under marine, we have winds, wave heights, and so forth. So some interesting information you can look at, not only to see what the NVM is showing, but looking at run-to-run consistency and how it's changing over time. Okay, before I move on, there are a couple other tools with regard to viewing this image that I'll point out. One, you can click on this toggle to go to full screen if you wish, and then toggle back. And there's also a button here if you wish to download an image. You have that option as well. So not a bad tool there to look overall at a variety of fields from the NVM, looking at run-to-run consistency and so forth. But there's actually more data available than that. There's actually point-based information. I pointed out earlier a number of these forecast points across our area of responsibility. You can click on any of these. I'm going to click on Jacksonville, and you'll see it comes up with Jacksonville and a link to a component point visualization. I'll click on that, and it's going to call up this display. You'll see on the map there's actually more points than was on the prior map as far as your options for what locations that you can click on to view this information from the NVM. So this can be somewhat confusing or intimidating, I guess, as far as trying to understand what you're seeing here. So I'll just kind of go through at least what I know anyway of understanding this. You have the fields available here. Here we're looking at maximum temperature. And if you scroll over these lines here, vertical lines, as you go through these, you'll see that there are different models being shown. Here this is the Canadian. Here we have the GFS. I scroll down the NavGem and so forth. European. So the main ones are shown here, so you can see how far apart they are or close together they might be for a given forecast. You also have QPF here, the box and whisker diagrams for QPF to see about forecast amounts. Below that you have the wind rows, and this shows you the distribution of forecast 10-meter wind speeds and directions, and you can click on this to see what percentage are showing this direction and speed range. For example, in this case, half are showing east-northeast between 0 and 9 knots and so forth. You can change the forecast period down here, so I click here and you can see that 2/3 are forecasting east at 0 to 9 knots, and we have 17% forecasting more like 10 to 20 knots for this location and this time period. So you can look at that as well. One other thing I wanted to point out for the top display here is there's a button over here called Deprog DT mode that you can click on. You have to go on the right side to click on. When it comes up, it'll show hourly NVM forecast for this field. So you see them hour by hour, and you can see consistency from 1 hour to the next, generally within a degree, as you see in this example. No major changes from 1 hour to the next. But here you see an example of a steady increase, a slow increase here hour by hour of max temperature. So you can look at that as well for NVM. I'm going to turn that off for the moment. On the lower right is a field you're probably not necessarily used to. It's called a violin plot, used to help look at the range of values from all the inputs within the NVM. And so here we see the max temperature values on the y-axis here. And you can click or move your mouse over and get a variety of information, the mean or the median values from all the inputs, where we have just a few inputs where it's fairly narrow, where we have a lot of inputs of that value, where it's wide, and so forth. And so you can get some sense, it become used to this kind of display for looking at where there's the greatest amount of agreement for all the inputs. There's a lot of inputs within the NBM. I assume you can't really display them all on this top image. So we're only looking at the top models here, but maybe more of it is incorporated within the violin plots. The displays look different as you look at different type of fields. If I looked at QPF, for example, we see an example where one model here is showing 24-hour rainfall of 3 inches for Jacksonville. And that is actually, if I have to go on this line here and come down, I can see it's the WRF ARW is showing 3 inches, whereas the NMM is showing quite a bit less. And then if you look further down, the WRF showing much minimal, and NAM is showing 0.1. And so in this particular example, we're seeing an unusual forecast with a single run showing heavy rain over Jacksonville, with all everything else is not. And when I go to 24 hours, if I look at this violin plot here, in general, it shows you the range for, as you see right now, since it goes up to 1 inch, the range shown here is 1 inch. But as I go ahead, you'll see there's a potential up to 3 inches. So if I move ahead, you're going to see that scale change to up to 3 inches. And you see it's picking up that forecast that's forecasting 3 inches, even though the majority are forecasting very little rain, only a few hundredths of an inch. But you can see this and see if it has any impact on the overall NBM result. Here's an interesting display of hourly temperature, and you can kind of get a sense. And you see on the lower image here, I can change go through each hour of the forecast and see where there's agreement or where there's not agreement. You'll see on this field we have 2 displays. We have the raw output and we have bias corrected output. This can be helpful for looking at when to use bias corrected as opposed to when to use raw. If the pattern hasn't changed in several days, you probably want to focus on bias corrected output. If there's a massive change in the pattern, you're probably going to want to focus on the raw. That might be the better approach. But you see here's an example where there is a bit of difference between the raw output and the bias corrected. There's even a more narrow range of values from bias correction. You also can see on the top here, just from a variety of inputs, the how much agreement or disagreement there might be on a particular hourly forecast. And you see pretty good agreement in the near term, but as you get several days out, the spread increases considerably, and so there's much greater uncertainty. In fact, you'll see as I go from near term to longer term, the spread of the y-axis shows much greater spread in this violin plot longer term than it is short term. Here's a very interesting example here where there's a substantial spread on the raw data, but the bias corrected is quite narrow, focusing on a specific value. In this hour, it's somewhat the opposite. Now we see a greater spread with the bias corrected than we do with the raw forecast data. So a pretty interesting tool for looking at the value and the level of certainty for a particular forecast based on the NBM. Now for the QPF display here, we're seeing the box and whisker displays for each forecast period. So when you overlay your mouse on a particular forecast, you see the range from the NBM from a maximum value of 1.79 inches for that 6-hour period all the way down, of course, to 0. It also shows what the median and the mean values are. In this case, both much less than 1.79 inches, but it gives you a sense of confidence in terms of the QPF forecast, as well as the range of possibilities. Okay, now I'm back on the main display page again. I'm going to look at one other thing for you, and that's aviation. Let's take a look at, for example, ceilings for aviation forecasts and see what can be shown here. So here we see an example. I'm going to zoom out. I can use the roller on the mouse or this tool here up here to zoom in or zoom out. And I'm looking at ceilings given in hundreds of feet. And I can see this is from a 12Z run, and it's an 18-hour forecast. I can change the forecast again here. Now I'm looking at a 12-hour forecast. So let's go back to 18. Let's see what happens in 24 hours. And you actually can, the periods, since we're looking at hourly forecast information, you actually can go down and look every hour and see what's going on. So here we see something going on here with regard to low ceilings here, and we're seeing values down to about 700 feet. So IFR conditions forecast in this area. Then I can also look at the hour-to-hour runs and look for dprog dt. Is it consistently showing these ceilings or not? And this is actually showing hourly model run changes. So if I look at the model run 1 hour earlier, it should update, and now it's showing the run for 11Z, the 24-hour forecast run for valid 11Z. If I go back 2 hours, now it's the 10Z forecast run that's valid for 11Z. Now it's showing even lower conditions, now down to 400 feet. So over time, the model, the NBM guidance has shown somewhat higher ceilings for this hour with time. And so it's actually been a steady trend upward between there and then there and to the latest run for this particular hour. So this is how you can quickly view not only NBM output, but how it changes in time and how the NBM forecast changes from one run to another for a variety of fields. This is a tool that you can use to try and efficiently look as you're going through your grid, looking at high and low temperatures, QPFs, pops, and weather, and so forth. You can quickly look and see what is consistent and where there's more substantial inconsistency, where there might be a potential target of opportunity. Thank you for watching the video. I hope it proves helpful for you. This can all appear a bit confusing and uncertain. It's just going to require some practice. So give it a try in operations and see if it can be a useful tool for recognizing targets of opportunity in the NBM era. As a side note, I should point out that I've had no role in developing this tool or in providing input on it. In fact, I haven't even had a shift to try it out in operations myself, given the telework status I'm in someday. So give it a try. And if a forecaster comes up to you and asks you what you're looking at, you just simply say, "What's up?" Thank you.